Now it's 1.2 Arithmetic Series. We all know series. Series means a sum, right? So we just add them together, so it's a sum. The sum is called a series. Okay. So obviously 3, if we have a 3 and 7 and 11 and 15 and 2 and we have this sequence, then because the common difference is all 4, now obviously this is a arithmetic sequence. Now we add them together, now it becomes a series. Okay. And then here, at least in the textbook, it does say how to derive, how we're going to prove how this formula comes up. See this formula, all right? So this looks rather complicated, but if we know how to prove it, it's not complicated whatsoever. So I just like to present you with my proof, which is different from the textbook. And now here, I do not know how many of you have heard this very famous story about Frederick Gauss. And Gauss is one of our most famous mathematicians in history, and his contribution to mathematics is absolutely number theory. All right, so therefore, the grade 7 and grade 8 math competition is named after Gauss, right? Because at that time, you're encouraged to be more interested in numbers. So the story goes like that. If you have heard about it, especially if you have been one of my students, probably you're just hearing this repeated story. But if any one of you have not heard it, I shall be very pleased to share with you the story. So Gauss, when he's very young, probably 7, 8 years old, he just learned arithmetic operations. And one time the teacher says, hey, entertain yourself about adding 1 plus 2 plus 3 plus whatever all the way to 97, 98, 99, and 100. So take your time. I just need to go out, make my coffee, and relax. So you guys, you just add them. When all the other children started religiously, diligently start adding, when teacher just about to walk out of the classroom, Frederick said, hey, no, please do not go. I have already got the answer. And the teacher said, what? What is the answer? He said, my answer is this. Add them together is this. And you can just tell that everybody is dumbfounded. They're like, how? Like, what? And so the teacher said, okay, show me. He says, yeah, well, this is, I don't add this, add this, add. So he said, I don't do that. This is what I did. I add the first number with the last number. And then respectively, I add the second with the second last, the third with the third last, and there's a 4, the 4 with the fourth last. So you can all tell that they're 101. And there's 101, 101, and how many 101 here? And there's 50, right? So then, of course, it could be saying 100 of 50 and add on another 50. And of course, it's 50, 50. Done? Now from here, of course, Frederick Gauss immediately being sent over to high school. So I think that when he graduated from university, he's probably only 13 years old. And he made tremendous contribution to number theory for mankind. So now this one, right after, extended to plus n. So this is called the consecutive from one after another, consecutive natural numbers. The sum of consecutive natural numbers, the formula is n multiplied by n plus 1 divided by 2. Now why is that? It's because you add 1 to n, that gives you n plus 1. You add 2 to n minus 1, and give you n plus 1. You add 3 to n minus 2, give you n plus 1. Now, how many total of these n plus 1? It is n divided by 2. Because here is 100 divided by 2, give you 50. Now here is n divided by 2, because the total, these 101, or the total of n plus 1, is half of all these pairs, right? So in the case of this, then if this A1, A2, A3, all the way to an minus 2, an minus 1 to an, if they're arithmetic sequence, that means there's a pattern. Doesn't mean these are just random numbers, you can put them together. That is not the definition of an arithmetic sequence. So in this case, if we add them together, then we can figure out what's going on here. So I'm going to use the same thing. This is, believe it or not, A1 plus to AN equals to A2 plus to AN minus 1. You pair them, they're equal. And you say, really? Why? Okay, well, let's see why. How can you make such a claim? Okay, well, let's see this. Because my A1 is A1, my AN is A1 plus N minus 1D. Is that right? Okay, well, this is my left-hand side. Now, my right-hand side, I got A2. Now, what is A2? A2 is A1 plus D. Now, what is N minus 1? Now, that is A1 plus N minus 2D. Right? Okay, well, I already proven this. So this is my right-hand side. Okay, so let's just organize it. So then, left-hand side, I got 2A1 plus N minus 1D. Okay, well, now let's take a look at my right-hand side. I got A1, I got another A1, so I got A1, 2A1, I got a D, and I got N minus 2D. Of course, then that means N minus 1D. There's a 1 extra D. Add on to this N minus 2. Right? So, seriously, that is N minus 1D. Therefore, my left-hand side equals to my right-hand side. Then that means this one add on to this one, they're equal. And in between, so A3 add on to A, N minus 2, they're also equal. So I can say, okay, I just rewrite this is called last term. Okay, so that use the L for last term. So then that means when I add them together, this is just as this formula tells us. It is your first term add on to the last term, first term add on the last term. That means that my A1 add on to my last term. And then how many of them? N divided by 2. That's my formula, all right? Now, in your textbook, they're saying, I'm just using this A1 equals to A. Oh, that's fine, right? Just different way to write it. Okay, so then that means the formula is N and A plus L divided by 2. You see this? All right. As a matter of fact, this is also proven by my Math 10 students. So after I told the story, pretty much everybody, I told the story about Gauss, pretty much everybody was able to think in such a way and figure out, oh yeah, right, that's just a formula, seriously. Here, take a look at this. This is just a formula here, all right? So now, in terms of, okay, well, the next one is just a transformation, as a matter of fact, from this one here. So then what does that mean? Okay, if we don't use the last term, fine, we don't use the last term, that's all right. So now here, now from here, what I would do, it's a different color. Okay, you don't want me to use the last term. I'm going to rewrite. Okay, so then that means n is just n here, and my a is my a1, and the plus, then what is my last term? As we said before, this is a1 plus n minus 1d, okay, and this is divided by 2, all right, divided by 2. Okay, so then you take a look at, well, this is a1 too, so there's 2 a1s here. So now I've got n divided by 2, and the bracket here now has 2 a1 plus n minus 1d. Okay, so multiply this in. Then I got this one and this one cancels. Now that means a1 multiplied by n plus, let's multiply by that. So n minus 1 divided by 2, and there's a d. And that's another way to write this formula, isn't it? Take a look at here. Yeah, well, they didn't multiply in, so then they're just saying, well, the formula is like this. Well, that's fine. So that's exactly the formula we just did this before. It's like, okay, well, you don't want to multiply in. Okay, that's fine. Yeah, as I said, yeah, you probably should not multiply in, because in the very end, it should be just a fraction, not a something add together. So, okay, well, sure. That just means you got n divided by 2, you got 2a1, and you got n minus 1d. And that's it. All right. So in terms of this section, do we even need to show any example? I don't think we do. All right, so this is just plug the formula, right? Plug the formula, and you should be perfectly fine. Yeah, no, these things, I think you should just try to do the exercise, and if you have any troubles, then come back to look at a couple of these examples and should be fine. Now, one thing to pay attention is called summation. So again, this is just a notation. All right, so this notation, it is just this your sequence, and then you add them from the term 1 to term 10. One thing needed to note or pay attention to is that if this is linear, if this is linear, then it's arithmetic series, right? But if it's not linear, then they don't have a common difference. Then that means if this is not linear, then it is not an arithmetic series, because it's not even an arithmetic sequence to begin with. Okay, so is there anything interesting here? Okay, so this might be interesting. So write in the summation notation. So that means you have to figure out this arithmetic sequence in a linear equation, form. Linear equation, you got to write out the linear equation in order to write the summation, right? So then how do we do the linear equation? Okay, well, first of all, we don't know how many terms this is, but we know the common difference. So then from here, we know the last term, then we can calculate the term number. The term number is 34. So we understand it is the adding is from a 1 to the term 34. So from here, we already got this one. It's 34 here, all right? So the next is we needed to write out this pattern, 5, 9, 13, and 137. This pattern, what kind of linear pattern is this? You already did this in grade 9. So the pattern is a common difference is 4, and you would figure out what is the B. right? You figure out what the B. So your common difference is, so anything your AN should be 4N. However, there must be a B here. Then what should the B? Then B should be 1 because your first term is 5, it's not 4. So then that is that. And then you write like that, and that's your formation. Okay. I think I can just stop here. There are definitely different interesting questions that basically test you some of the number sense. Now, for example, this question will be interesting because it's adding on the radicals. Which one is also interesting? Summation part, I find this one is very interesting. It's just because I had my own way to calculate this, and it just makes the calculation easier. So any of you want to try these questions? That's interesting. These questions interesting, 7, 8, 9, 10, 11, 12, 13, 14. These questions are interesting. It just a little bit, you just need to read more, but basically it's the same thing. Okay.